Hello everybody, we are going to discuss today the topic heat, temperature and thermal expansions. I am Srinivasa Charyulu dealing the topic. We in fact know from heat and thermodynamics part at EAMCET examination we will be getting a minimum of 3 questions. Out of that 3 parts we can make that one into. One, the very first part, heat, temperature and thermal expansions. Thermal expansions in the sense expansion of solids, liquids and even gases. All these concepts we are going to take up today. Heat, in fact, we know while taking up the basics of this particular topic, heat is a form of energy which is going to be measured in terms of temperature. You all in fact know well the degree of hotness or coldness of a body is generally taken as temperature, and thermometer is the one which is used to determine the value of temperature of a body. When you recollect the concept of thermometer, particularly liquid thermometers, Celsius thermometer, which of course is between 0 and 100 degrees centigrade. 100 parts exactly you are going to find here. Second one, Fahrenheit, you will be finding between 32 degree Fahrenheit and 212 degree Fahrenheit. Exactly 180 parts we people are going to have in between. So first theoretical point one should remember here is Fahrenheit is more accurate than Celsius. Coming to the next one, that is Kelvin, absolute temperature we used to call it, 273 Kelvin to 373 Kelvin you will be having. In between these two, once again we are going to have exactly 100 parts. Down below this one, this extends up to 0 Kelvin, which now is going to be 273 degrees centigrade with a negative value. So this is the least possible value of temperature one can expect of a particular body. So if you recollect once again, what is the relation between these three is the first concept. C by 100 is equal to F minus 32 by 180 is equal to K minus 273 by 100. This is actual formula. But in fact, this is going to be compared with a faulty thermometric scale. If I consider that faulty scale as a X scale, then X minus lower fixed point divided by upper fixed point minus lower fixed point. This difference gives you the number of parts which we have made between the minimum and maximum values. So this is one particular formula you need to remember before entering into the applications part of it. One. Come to the second one. While discussing about expansion of solids, linear expansion, areal expansion and cubical or volume expansion we people used to take up. One, of course, linear expansion coefficient alpha we write, which of course is change in length by original length into rise in temperature per degree centigrade. And of course superficial expansion or areal expansion, beta is equal to change in area by original area into variation or change in temperature. And if you take the third one, that is cubical expansion, that we used to take change in volume by original volume into change in temperature or increase in temperature. But in fact we all know very well beta is taken as 2 alpha and gamma is taken as 3 alpha. These are the basic things. Alpha is to beta is to gamma is equal to 1 is to 2 is to 3. That is the formula one should remember before entering into the applications of this. One more, I just want to mention what are the applications of this expansion of solids we are having. The very first one is how much amount of gap that is to be placed between two successive rails, like that of course we used to take it as delta L, which is L into alpha into delta T. L is the original length, alpha is coefficient of linear expansion of that particular metal, and delta T is going to be the variation in temperature, either increase in temperature or decrease in temperature, whatever that is. And coming to the next one, please. What exactly is going to be the concept of thermal stress? This in fact we people have discussed earlier also. in one of the chapters, that was this elasticity. Thermal stress F by A, we can now write Y alpha delta T. Y for Young's modulus, alpha for coefficient of linear expansion, delta T for the variation in temperature. What is going to be thermal force therefrom? You can write Y alpha delta T into A. This is another application we have to take up. Coming to the next one, what is going to be the loss or gain in temperature, gain in time, shown by a clock which is a pendulum clock due to the variation in temperature? That of course we used to take delta T is equal to half alpha delta T into 86,400 if it is per day if you want. Otherwise, according to the time in which you want to have the variation in time there, that much of value you should write it over there. So this is actually the change in time shown by a pendulum clock when there is a change in temperature existing at that particular place, that is delta T as such. Alpha is coefficient of linear expansion. Out of all the different metals, of course, we know very well brass is going to have greatest value of alpha. Remember that. And coming to the next application over here, at every temperature, the difference between the lengths of two different metals like this, metal rods, to be same, then we can understand L1 alpha 1 must be equal to L2 alpha 2 is the formula. In other words, we can say L1 by L2 must be equal to alpha 2 by alpha 1. And in addition to that one, we people are having a bimetallic strip having two different metals, which of course have got different values of alpha. If alpha 1 is greater than alpha 2, when heated, you will be finding the system is going to be bent this way. That means the one which is having greater value of alpha will take a convex shape. The one which is having the lesser value of alpha, that of course will be towards concave side. Exactly like that, if alpha 2 is greater than alpha 1, this comes over there and that comes over here. This is the concept. What will be the radius of curvature? It is the thickness of this particular bimetallic strip divided by delta alpha into delta T. Delta alpha is nothing other than change in linear expansion coefficient of the metals, and delta T is going to be the variation in temperature. So these are the applications one should remember as far as expansion of solids that is concerned. Likewise, if you look at expansion of liquids, gamma real is equal to gamma apparent plus gamma of glass or the vessel, whatever has been taken, into which the liquid has been taken in fact. In other words, you can write gamma apparent plus 3 alpha. That is the equation for gamma real. But remember carefully, gamma real, whatever the vessel you are taking into that particular liquid, it is going to be constant. Gamma apparent depends on the vessel, but gamma real does not depend on anything else. Gamma real will definitely be a constant over there. That is the point. Coming to the next one, how do you calculate gamma apparent in this case? Gamma apparent is equal to weight of liquid expelled. How much liquid that has been expelled from that specific gravity bottle, divided by weight of remaining liquid, how much liquid that is now remaining in that SG bottle, into change in temperature or rise in temperature. This is the usual formula by means of which we can take up the value of gamma apparent. So mainly one should concentrate on these two formulae. In addition to that, the concept of anomalous expansion of water, in which between 0 degrees to 4 degrees, when you heat up water, it contracts, and from 4 degrees to 0 degrees, when you cool it down, it expands. That is a strange type of expansion which is observed in the case of liquid like water. That is what is called anomalous expansion of water, and we all know the reason also well. Water has got maximum density and minimum volume at 4 degrees centigrade, not at 0 degrees like other liquids as such. So these are the points we have to remember as far as expansion of liquids that is concerned. If you take up expansion of gases, the very first equation we need to know is PV is equal to constant at constant temperature, which is called Boyle's law. Its applications of course can be taken P1 V1 is equal to P2 V2, P1 by P2 is equal to V2 by V1, P1 by rho 1 is equal to P2 by rho 2 in terms of their densities. These are the other versions of this. Likewise, we know very well when volume is kept constant, pressure of the gas, a particular mass of a gas, is directly proportional to its temperature, absolute. Likewise, when pressure is kept constant, volume of certain mass of a gas is directly proportional to its absolute temperature. In addition to that, you have discussed about PV is equal to nRT, that is the gas equation what we used to take up, where from P1 V1 by T1 is equal to P2 V2 by T2 is the other version of this equation. Likewise, P1 by rho 1 T1 is equal to P2 by rho 2 T2. This is another version of the same equation one has to remember. And mostly applications of Boyle's law are to be taken care of, because many a number of times in the past that fellow has asked questions based on this Boyle's law and its applications as such. So these are the areas, in fact, one should remember before taking up the applications part of it. And again, we will be knowing very well in this particular case that any gas used to have one pressure expansion coefficient and one volume expansion coefficient, alpha V. That is, of course, we used to write that one either as alpha or beta. One is pressure expansion, one is volume expansion. Each one is equal to 1 by 273.15 per degree centigrade. In other words, 1 by 273 per degree centigrade we people used to take up, whether it is coefficient of volume expansion of the gas or coefficient of pressure expansion of the gas, whatever be the case, value remain the same, but they have their individual concepts like. So these areas one should remember or recollect before taking up the applications part of this particular chapter as such. So let us now check up some of the questions based on all these formulae whatever we have taken up. A faulty thermometer has its fixed points marked at 6 degrees and 96 degrees. The correct temperature on the centigrade scale when this thermometer reads 87 degrees is how much? In fact, we all know Celsius scale we just want the value in centigrade. So C by 100 is equal to this faulty thermometric scale, if I take it as x minus lower fixed point by upper fixed point minus lower fixed point. This is actually the formula I have already told you. Then how to write this value? C by 100 you take it as it is, no change in that. And x is given how much in the problem? It is given 87, fine. What is lower fixed point? That is given 6 by upper fixed point is 96 and lower fixed point is given 6. Then you can write 81 divided by 90. That is actually the concept. Now cut this 0 and this 0 please. So this 9 cancels here 9 times. So what will be the value of C now? Cross multiplication gives you 90 degrees. So what is the corresponding value over here please? 90 degrees centigrade is the corresponding value for the value of 87 degrees given on the faulty thermometric scale as such. So if you look at the options carefully, the very third option that is coinciding with this particular concept, that is 90 degrees centigrade, is the right option for that first question. Let us check the second one please. One of the important most applications of expansion of solids. The length of each rail is 10 meter and coefficient of linear expansion of its metal is 12 into 10 power minus 6 per degree centigrade. If the temperature increases by 15 degrees centigrade, the gap to be left between two successive rails will be how much? Just now I have mentioned that corresponding formula. Delta L, if I consider this one to be the gap that is to be placed between two successive rails as such, it now can be written as L into alpha into delta T. I have already mentioned that L is the original length of that each rail. How much that has been given here? 10 meter. Usually at Indian standards, the length of the rail is going to be 10 meter. And of course, what is alpha? 12 into 10 to the power minus 6. That's the value of alpha given. And what is the variation in temperature? You look at temperature increases by 15. Just take this one as 15 please. Now you can definitely understand this 0 gets cancelled here minus 5 times. Right. Now this is 180 into 10 to the power minus 5. 0 you can cut it off minus 4 times. So 0.0018 what? Meter. This must be the gap that should be placed in between two successive rails as such. Look at the option carefully. Out of the given 4 options, the very first option that is tallied for this question number 2 as such. This is question 2 and option is 1 for this. Let us check the next problem, that is question number 3 as such. The pendulum of a clock is made of brass. If the clock keeps correct time at 20 degrees centigrade, how many seconds per day it loses at 35 degrees centigrade? Observe that wording carefully. How many seconds per day? In 1 day's time, what is going to be the variation of time that has been shown by that pendulum clock? That is the question. Just now I have given you delta t, that is the variation in time whatever is showed by that pendulum clock, which of course is made up of a metal, in this example as brass. If you take this one, half into alpha into delta small t, or you can even represent this one as delta theta also. Whatever you write, delta theta or delta t, that represents the variation in temperature. Per day we want, in 1 day, 86,400 seconds we will be having in a day. So one should write that value here. Suppose in the question if it is asked per 1 hour, then 86,400 should not be written there. 1 hour is 60 minutes, each minute is 60 seconds, so 3,600 seconds you have to write there. So automatically half into, what is the value of alpha that is given of brass, you look at 2 into 10 to the power minus 5 into, what is the variation in temperature, you look at 20 degrees centigrade it was showing correct time. 35 degrees centigrade it is just giving us a wrong time. That in the sense what? 20 and 35. The difference is going to be 15 into 86,400. Exactly, if you take this 2 getting cancelled, 2 zeros you can cut that one minus 3 times. Now you will be getting 864 into 15. Right? Into 10 power minus 3, so many seconds. If you just simplify the whole thing, you will be getting that one exactly 12.96 seconds please. That means what you should understand here, you look at, no doubt 12.96 seconds is the variation. Variation means how? One should understand temperature is increasing. That means length of that pendulum will increase. When length increases, time period increases. When time period increases, frequency decreases. That means this much of time it goes slow. That is the concept one should have in memory. So the correct option for this third question is 12.96 seconds as such. That is question number 3 as such. Now let us check the next problem, that is problem number 4. A crystal has coefficients of linear expansion along 3 mutually perpendicular axes as 4 into 10 power minus 5, 5 into 10 power minus 5 and 6 into 10 power minus 5, all per degree centigrade respectively. The coefficient of cubical expansion of the crystal would be how much? One should understand, for some of the crystals they used to expand in different directions differently. Now in this particular case, alpha of the resultant system, if you just want, it is alpha x plus alpha y plus alpha z by 3. Simple average that gives you the value of alpha. But he is not asking you alpha. He is asking you what is coefficient of cubical expansion, gamma. So can't you write, is it not 3 times alpha of the resultant please? 3 getting cancelled, what is left over? Alpha 1 plus alpha 2 plus alpha 3. If you simply add these 3 and write, that itself gives you the value of gamma. What are the values given? You see, 4 into 10 power minus 5 plus 5 into 10 power minus 5 plus 6 into 10 power minus 5. 6 plus 4, 10. 10 plus 5, 15 into 10 to the power minus 5 per degree centigrade. So what is the correct option over there, please? 15 into 10 power minus 5. So second option is the correct option. Don't be misled once again. First option says 15 into 10 power minus 6 there. It is 10 power minus 5 we people are getting. Therefore, second option is the correct option for this question number 4 as such. Let us check the next question, please. Question number 5. A brass rod of cross-sectional area 4 centimeter square is heated through 10 degrees centigrade and prevented from expansion. The thermal force exerted on the clamp to compensate its expansion would be how much? For brass, alpha is given 2 into 10 power minus 5 per degree centigrade and Young's modulus Y is given 2 into 10 power 10 Pascal as such. What is the question that is asked? Thermal force that is needed. That means even after giving heat energy and expanding that particular rod also, its expansion should be nullified by applying some external force per unit area. That is what actually is called thermal stress. In this particular question, thermal force that is asked, Y into alpha into delta T into A being area of cross section. So look at the values given carefully, please. 2 into 10 to the power 10 Pascal is the value of Y as such. And what is that value of alpha given? 2 into 10 to the power minus 5 that has been given here, please. What is the change in temperature? 10 degrees centigrade it has been heated through. Therefore, 10 degrees you take it as it is. What will be the area, please? 4 centimeter square. Write 10 power minus 4 meter square. 4 into 10 power minus 4. You now can write this way. 10 power minus 5, 10 power minus 4, 10 power minus 9. That gets cancelled 10 times here. Now 10 into 10, 100. 100 into 4, 400 into 4. So 1600 you will be getting what? Newton. Look at those options carefully. 160 Newton the first option, 1600 Newton the second option. So automatically the second option that's going to be tallied. All of you remember this equation thoroughly. If they ask you by any chance what is the stress required, you have to write F by A for it. It is Y into alpha into delta T. That is the change you have to make for that particular question number 5 as such. Now let us check the next question, that is question number 6 as such. Two metal rods A and B have coefficients of linear expansion 1.1 into 10 power minus 5 per degree centigrade and 1.65 into 10 power minus 5 per degree centigrade respectively. The difference in lengths of the rods is 10 centimeter at all temperatures. The initial lengths of the rods A and B respectively are. In fact, alpha 1 is given to us and alpha 2 is given to us. One is 1.1 into 10 to the power minus 5 given. And the second one is 1.65 into 10 to the power minus 5 per degree centigrade, of course given in both the cases. But one should understand at all temperatures the difference between their lengths to be 10 centimeter means what? I already have given you that concept. L1 alpha 1 must be equal to L2 alpha 2. This should be the equation. That means what I can write? L1 by L2 must be equal to alpha 2 by alpha 1. What is alpha 2? 1.65. What is alpha 1? 1.1. Because 10 power minus 5 gets cancelled. So looking to this equation, can't you understand L1 is greater than L2, please? Therefore, L1 minus L2 must be 10 centimeter. That is the concept. So what are the two equations you are getting now? L1 by L2 is equal to 1.65 by 1.1. L1 minus L2 is equal to 10 centimeter. Just look at these two values carefully, please. L1 you can write it as 10 plus L2, that you write it here. Or L1 you can write from this one as 1.65 by 1.1 into L2 from the first equation. Come on, substitute that one over here. L2 if you take common, 1.65 minus 1.1 by 1.1, that is equal to 10 you will be getting. What is 1.65 minus 1.1, please? It is L2 into, this is now 0.55 by 1.1. If you multiply this one over here, this becomes 11 times, please. Now look at carefully, L2 now becomes 11 by 55 into 10 power minus 2. This goes 5 times. 1 by 5 is 0.2 into 10 square. That means how much it is? 20 centimeter. So L2 is 20 centimeter means L1 definitely should be 10 centimeter more than this. That means it should be 30 centimeter. Look at the options 30 and 20. Which option that is correct over there? The fourth option, that's giving us 30 centimeter for the length of the first rod and 20 centimeter being the length of the second rod. So fourth option is correct for this one. Let us take the next problem, that is question number 7, please. Look at that question once again. Two rods of different materials having coefficients of linear expansion alpha 1 and alpha 2. Their Young's moduli are y1 and y2 respectively and are fixed between two rigid walls. The rods are heated such that they undergo the same increase in temperature. That means delta T is constant in both the cases. There is no bending of the rods. Means what? It has been compensated by applying some external stress. If alpha 1 is to alpha 2 is 2 is to 3, the thermal stress developed in both the rods are equal provided y1 is to y2. No doubt the question is looking very lengthy. But what is the concept here? Underline that wording carefully. If alpha 1 is to alpha 2 is to 2 is to 3, thermal stress developed in both the rods should be the same. That means y1 alpha 1 delta T must be equal to y2 alpha 2 delta T. Since delta T value is same for both the metals, he has given both the rods, then y1 by y2 can be written as alpha 2 by alpha 1. What is alpha 1 is to alpha 2 ratio given? 2 is to 3. So reverse that one. 3 is to 2 must now be the ratio of Young's moduli of both the materials of the rods. Now look at the options once again carefully. The third option is given 3 is to 2. So that will now be the correct option for us as far as question number 7 that is concerned. Look at the next number, please. Two uniform metal rods of lengths L1 and L2 having coefficients of linear expansion alpha 1 and alpha 2 respectively are connected to form a single rod of length L1 plus L2. When the temperature of the combined rod is raised by T degrees centigrade, the length of each rod is increased by the same amount. That means what is increasing here? Length is increasing in the equal way. Then what is alpha 2 by alpha 1 plus alpha 2? Look at first of all the wording carefully. He is talking about the increased length is going to be same. That means delta L is going to be same. L alpha delta T, that is actual formula. And of course you people can understand delta L is same for the first one means you can write this one delta L is equal to L1 alpha 1, right, and second one is going to be L2 alpha 2. Then what exactly you can understand from this one? L1 by L2 is equal to alpha 2 by alpha 1. That is the general concept. Suppose if I add 1 on both sides, I will be getting L1 plus L2 by L2. You can understand that one carefully here. Is equal to alpha 1 plus alpha 2 by alpha 1. But his question is not this. He is asking you alpha 2. Therefore, simple variation we just have to make it. What is that concept here? You write L2 by L1 is equal to alpha 1 by alpha 2. Now add 1 on both sides once again please. L1 plus L2 by L1 is equal to alpha 1 plus alpha 2 by alpha 2. Come on, reciprocate this one. Alpha 2 by alpha 1 plus alpha 2 is equal to L1 by L1 plus L2. Look at this one carefully. Alpha 2 by alpha 1 plus alpha 2 is how much is the question? L1 by L1 plus L2. Check the options thoroughly. The very first option that is exactly like this, L1 by L1 plus L2. So for the 8th question, the very first option option is the correct option. One should understand what is constant for both the materials. It is delta L, which is the change in length, that is constant in this particular question. Same question has been asked in one of the papers of EAMCET earlier, right? Let us check the next problem. Problem number 9 this time. Look at that concept carefully. A bimetallic strip of brass and steel, each having thickness of 1 centimeter at 20 degrees centigrade, is heated to 120 degrees centigrade as such. It bends with brass on the convex side, obviously, because I have already given you in the beginning itself, out of all the metals, brass is having the greatest value of alpha. Then automatically that will be seen towards the convex side when it is being bent after being heated. It bends with brass on the convex side. If alpha of brass is 18 into 10 power minus 6 per degree centigrade and alpha of steel is 12 into 10 power minus 6 per degree centigrade, then the radius of curvature of the curved surface will now be how much? That is the concept. What is radius of curvature formula? I have already given you thickness by delta alpha into delta t or delta theta, you write. You should not have any confusion here. T for thickness, delta theta for variation in temperature as such. So let us check this one. Thickness being 10 power minus 2. It's 1 centimeter given. Fine. What is delta alpha? 18 minus 12. It is 6 into 10 to the power minus 6. That's the value what has been given. Into what is the variation in temperature? You look at 20 degrees to 120 degrees. So exactly 100 degrees will now be the variation in temperature. This of course cancels minus 4 times. This cancels minus 2 times. So 1 by 6 into 10 square you can directly write. That is 100 by 6. In other words, I can write 50 by 3, which now becomes 16.666 like that. You'll be getting, which of course I can make that one as 16.67 meter. So what is the radius of curvature of that brass piece over there? It is going to be 16.67 meter. So which option that is correct over there? You check it. Very first option, that's going to be correct. Okay, so this is the concept of bimetallic strip. Remember this formula thoroughly. Let us check the next problem. Problem number 10. This also has been one of the EAMCET questions earlier. Two uniform bars of lengths L1 and L2 with coefficients of linear expansion alpha 1 and alpha 2 are joined to form a longer rod of length L1 plus L2. The effective coefficient of linear expansion of the composite bar is how much? That is the concept. In fact, we can understand directly. If a change in length I want for the first bar, L1 into alpha 1 into delta t. That is the formula for delta L. For the second bar, what is the formula? L2 into alpha 2 into delta t. Suppose when I club those two to form a single big bar, then what will be this equation for that? L1 plus L2 being the total length into alpha effective into delta t. This is of the resultant bar, this is of the first bar, this is of the second. Now if you cut this delta t throughout, what is now left over? Alpha of the effective rod or the resultant rod after these two are attached to one another, that is now going to be L1 alpha 1 plus L2 alpha 2 by L1 plus L2. This should be the corresponding equation. Look at those options carefully once again. The second option that is being tallied there, L1 alpha 1 plus L2 alpha 2 by L1 plus L2, that is the corresponding formula for effective rod, the value of alpha of the effective rod as such. This is question number 10, what we have, for which the option is the second one there. Let us check the next problem, that is problem number 11. These questions are now from expansion of liquids we people are taking up now. All of you know the basic equation gamma real is equal to gamma apparent plus 3 alpha. For a liquid when heated in a vessel, it is found that its coefficient of apparent expansion is equal to 6/7 times its coefficient of real expansion. Gamma apparent is equal to 6/7 times gamma real. This is the equation mentioned. That is a relation in fact. Then what is the coefficient of linear expansion of the vessel? That means what is the value of alpha? That is what he is asking. In fact, we all know gamma real is equal to gamma apparent plus 3 alpha. This is the equation which we all know. But see carefully whether gamma apparent is to be changed from this equation or gamma real is to be changed from this equation. How do you identify that one? See the options carefully. All the options are given in terms of gamma r. That means we don't need this gamma apparent to be here. Then what should I write? Gamma r is equal to 6/7 times gamma r plus 3 alpha. That is the equation. So what I can write now? 3 alpha is equal to gamma r into 1 minus 6/7, which now is going to be gamma r by 7. But we want the value of alpha. What is this one now? Gamma real by 21. 3 times 7 will now become 21 there. So what is the correct option that is tallying? Very first option, which is gamma real divided by 21. That is the correct option one should remember for this particular question number 11 as such. Look at the next number please. 1 liter flask contains some mercury. It is found that at different temperatures, the volume of air above the surface of the liquid in the flask remains the same. If coefficient of linear expansion of the flask is 9 into 10 power minus 6 per degree centigrade and coefficient of volume expansion of mercury is 1.8 into 10 power minus 4 per degree centigrade, the volume of mercury taken in the flask is how much? One should understand what is the concept behind first of all. Suppose when you are taking up a flask like this, say a conical flask or directly any other type of a cylindrical vessel or whatever it is, you have taken some liquid into it, even here also. Above this liquid, whatever the volume of air you are finding, at every temperature that particular volume should remain constant. Means what? The level of this liquid should not be varied even when you heat it up or when you cool it down. That is a logical concept. That means what you should understand for this, it is possible only when V into gamma of that vessel and V into gamma of that liquid are equal. That means what should I write here? V of the flask into gamma of the flask. That now should be equal to volume of liquid into gamma of that liquid as such. Now what are the values? His question is, what is the volume of mercury that is taken? That means volume of mercury when you want. It is volume of the flask into gamma of the flask divided by gamma of the liquid. What are the values he has given you? Gamma of the liquid of course is nothing other than gamma of mercury in this particular case. Now let us check what is volume of the flask. 1 liter. 1 liter is 1000 cc. You can understand. Cubic centimeter can be written as 10 power minus 6 meter cube. Then automatically it comes to be 10 power minus 3 meter cube. That is the volume. So 10 power minus 3 you should write. What is gamma of the flask please? Is it not 3 times the value of alpha that is given please? It is now 27 into 10 to the power minus 6 like you can take up. What is the value of gamma of mercury now? Look at it is 1.8 into 10 to the power minus 4. Come on, just to simplify the whole lot, you will be getting exactly 150 milliliter. That is also can be written 150 cc. That will now be the value of mercury that is to be taken up. But one more thing you should understand in this case. If the vessel is made up of glass and mercury is taken in that, nearly 1/7 times the volume of the vessel. If you take volume of mercury, then you will be finding the same effect over there. Gamma 1, this V1 is equal to gamma 2 V2. That's going to be valid for mercury and glass combination like this. So the correct option for this 12th question is going to be the first option as such. Look at the next question, that is problem number 13. The ratio of coefficients of apparent expansion of the same liquid in two different vessels is 1:2. Coefficients of apparent expansion is 1:2. That is gamma apparent 1 by gamma apparent 2. That is equal to 1/2. I better write this one as gamma 1 by gamma 2 for my easiness. So gamma 2 can be written as 2 gamma 1. That is the relation. Now what else he has given? If alpha 1 and alpha 2 are the coefficients of linear expansion, then coefficient of real expansion of the liquid is how much? Gamma real is equal to gamma apparent 1 plus 3 alpha 1 for the first vessel. That is also written gamma apparent 2 plus 3 alpha 2 for the second vessel I can take up. Now out of this one, look at carefully what is the value of gamma 2. You can write gamma 1 plus 3 alpha 1 is equal to 2 gamma 1 plus 3 alpha 2. Now bring this gamma 1 that side please. You will be getting gamma 1 is equal to 3 alpha 1 minus 3 alpha 2. Now you can understand gamma 1 is in the first equation for us. Therefore, gamma real is equal to gamma 1 plus 3 alpha 1. What can we write? 3 alpha 1 minus 3 alpha 2 plus 3 alpha 1. What will be this value now? 6 alpha 1 minus 3 alpha 2. Look at that equation once again please. 6 alpha 1 we should have, 3 alpha 2 we should have with a negative sign. Fourth option, that is exactly coinciding with this particular calculation whatever we have made for this question number 13. So fourth option is the right option for this question number 13 please. Look at the next problem, that is question number 14. A solid floats in a liquid at 20 degrees centigrade with 75% of it is immersed in the liquid. One should straight away understand that 75% that is immersed inside the liquid means the volume of that body at 20 degrees centigrade is going to be 3/4 times the original volume. What for 3/4? 75 by 100. If I cut that 125 in both numerator and denominator, I be getting 3/4 into V. What next he has given? When it is heated to 100 degrees, same body floats with 80% of it is immersed in the liquid. Then volume at 100 degrees centigrade is equal to 80 by 100 of V. That is 4/5 times of V as such. What is the question asked? The coefficient of real expansion of the liquid is how much? That is the concept. In fact, we know V at 100 is equal to V at 20 into 1 plus gamma into 100 minus 20. That is the temperature variation what we used to write it. Now what is V at 100 we know? That is 4/5 by 3/4. That means 4/3 is equal to 1 plus gamma into 80. That is the equation what we are having. Now check this one carefully. Gamma times 80 is equal to 16/15. Now you can write gamma is equal to 16/15 into 80. You directly can take 4 times 4 here and here 20 times. So this one of course 5 times. So what is this 1/75? Whatever the value you will be getting, that will now be your answer. Which one that is going to be rather taken up over here? Directly you multiply the things over there and finalize, you will be getting exactly 8.33 into 10 power minus 4. Ultimate equation one should remember is going to be this one over here. So this is having an equation that is actually the value second option 8.33 into 10 power minus 4. Come on, take this equation thoroughly and substitute the values and simplify that one. So 14th question has got the second option as the right option for us. That is the point. Now check the next problem. Question number 15. This also has been one of the EAMCET questions earlier. The apparent coefficient of expansion of a liquid when heated in a copper vessel is C. Apparent expansion coefficient, that of course you can understand gamma apparent is equal to C in a copper vessel, and when heated in a silver vessel it is given delta. Same gamma apparent is going to be given delta. This is in copper vessel and this one is in silver vessel. Now the question is, if A is a linear coefficient of expansion of copper, then linear coefficient of expansion of silver is how much? That is a concept. Come on, write gamma real for copper first. It is gamma apparent plus 3 alpha. What is that alpha that has been given? 3A. That is in copper vessel. What about the silver vessel now? We can take delta plus 3x you can write. X is going to be the linear expansion coefficient of the second vessel. So if you equate these two, how much you will be getting as X, please? C plus 3A minus delta whole divided by 3. Look at this option carefully, please. Second option is going to be true. C plus 3A minus delta whole divided by 3. That will now be the corresponding formula for X as such. That is question number 15. Look at the next problem, that is problem number 16. A vessel containing 9 liters of an ideal gas at 760 millimeter of pressure is connected to an evacuated 9 liter vessel. What will now be the resultant pressure of the system? Now from this question onwards, we are having some of the applications of expansion of gases as such. Look at the first one. You can understand a vessel containing 9 liters of an ideal gas at 760 millimeter of pressure. So P1 V1 plus P2 V2 is equal to P into V1 plus V2. When temperature remains constant, on application of Boyle's law, we will be getting this equation. But be careful, the second vessel is evacuated. That means it hasn't got any pressure. So this value automatically will be cancelled. So what is this pressure now? P1 V1 by V1 plus V2. What is P1 that is given us over there? 760. If you take the volume as 9 liter here, 9 plus 9 is going to be 18 here. This goes twice and this goes 380 times. So what will now be the corresponding pressure, please? 380 millimeter of mercury pressure is going to be the effective pressure of the gas when evacuated chamber is connected to the main vessel as such. So option for this question number 16 is going to be the first one as such. Look at that next problem, that is problem number 17, please. An air bubble rises from the bottom of a lake and its radius is doubled on reaching the surface. If the temperature is constant, the depth of the lake is how much? 1 atmospheric pressure is equivalent to 10 meter height of water column as such. This also is one of the EAMCET questions earlier, please. One should understand when the air bubble is coming from bottom to the top of the lake, PV at the bottom of the lake now must be equal to PV at the top of the lake. That means according to Boyle's law, when temperature remains constant, P1 V1 must be equal to P2 V2, or PV at the bottom of the lake must be equal to PV at the top of the lake. What is the pressure at the bottom of the lake, please? It is atmospheric pressure plus H rho G. H rho G, that is actually the case. What is the value atmospheric pressure given? 10 meter of mercury that has been given here. H rho G we can take up here. This is the concept. But rho G here also we should take. So I should take this one common over here as rho G. That is the point. Into what is the volume? 4 by 3 pi r cube, because it is a bubble which is spherical by shape. Now what about the pressure at the top? It is simply 10 into rho into G. that of course we can understand H rho g once again, into what will be the volume now? 4 by 3 pi, R is being doubled, then automatically you can write 8R cube over here, because 2R whole cube. 4 by 3 pi R cube you can cancel over here. Rho into G you can cancel over here. Now what is left here? 80 is equal to H plus 10. Then what will be the value of depth of that particular lake? It is now 70 meter as such. Look at those options once again. Second option is given 70 meter. So it is a clear-cut application of Boyle's law once again for this question number 17 as such. Look at that next problem. Problem number 18 now. A vessel contains a gas under a pressure of 5 into 10 power 5 Pascal. If 3/5 of the mass of the gas is flown out, be careful in the wording. 3/5 has gone out of the vessel means how much is remaining? Only 2/5 is remaining. According to that only, you will be having the corresponding pressure now. What is the earlier pressure given? It is 5 into 10 to the power 5. Now how much is left inside? It is 2/5 that is left inside, because 3 by 5 has gone. Now 5 getting cancelled. 2 into 10 to the power 5, whatever the units he has given as Pascal must now be the pressure that is going to be taken up. So what is this 2 into 10 power 5 officially can be written as multiply and divide by 10. You will be getting 0.2 into 10 to the power 6 Pascal. 10 power 6 is called million or mega. So 10 to the power 6 you can write this one as million Pascal as such. So what is the correct option for this question you look at? Third option is going to be the correct option for this question number 18. Look at that next problem, that is problem number 19, one of the excellent models. Same question also has been repeated in one of the EAMCET examinations earlier. How much should be the pressure of the gas be increased to decrease the volume by 10% at constant temperature? That is actually the concept. Now look at carefully, P is proportional to V, 1 by V. P is inversely proportional to V or directly proportional to 1 by V. That is the concept. Now volume should be reduced by 10%. So you take initial volume as 100. Write this equation. Now when it is reduced by 10%, the present value becomes 90 now. And when this decreases, this should increase by some value. I take that one as X now. Then what can I write? P plus X by P, which can even be written as 1 plus X by P, is 1 by 90 by 1 by 100, that is 100 by 90, which is simply 10 by 9. Then what will be X by P please? 10 by 9 minus 1, which is 1 by 9 as such. Now I want percentage variation. What is that percentage means into 100? How much will be left now? 1.11. 11.11% will now be the increasement in the pressure of the gas as such. Look at the option carefully. Option 3, that is 11.11% as such is the correct option for us. Now look at that next problem, problem number 20th. Two closed vessels of equal volume contain air at 105 kilopascal and 300 Kelvin. And are connected through a narrow tube. If one of the vessels is now maintained at 300 Kelvin and the other at 400 Kelvin, then the pressure becomes how much? Look at carefully, apply the concept of gas equation over here. Pressure is given, the temperature also is given, volume also is given. So you can understand the first one, 105 is the pressure, volume is V and temperature is 300 Kelvin. Second also has the same value initially, V by 300. So P1 V1 by T1 plus P2 V2 by T2. After that, one of the vessels is now maintained at 300. That means it has got the same pressure and same volume again. And what about the other one? It's made 400. Then P into V by 400 I can write. V throughout I can cancel that one. Now what addition thing we shall write now? P by 400 must be equal to 105 by 300. This and this they get cancelled. 105 by 300 you will be getting. Come on, cut these things please. This one of course 35 times it goes now. What will now be the value of P? Exactly you will be getting this, of course you will be getting 15105. So whatever the value you will be getting after cross multiplying this one, that will now be the corresponding pressure. What is the corresponding answer for this one? It should now be 104, 120 plus 20. It should be now 140 please, not 120. Check that one carefully. So correct option is going to be according to this one, you have to get the first one. So check that 20th question like that, 120 kilopascal. Now look at the next one please. Question number 21. During an experiment, an ideal gas is found to obey a law V square P is constant. One of the very important models this one is. V square P is constant is talking about. What the question is asking? The gas is initially at a temperature T and volume V. When it expands to a volume 2V, the temperature becomes. Volume is increasing and temperature is changing, but pressure is not given. PV is equal to RT I can take, and P can be written as RT by V. Come on, substitute that one here. V square into RT by V is constant. In other words, V getting cancelled, V into T remains constant. Then what you can understand? V and T are inversely proportional to each other. When volume becomes 2V, then automatically temperature becomes how much now? Half. So which is the correct option for that? The fourth option will now be the correct option for this question number 21. Look at the last number in this particular order please. Two gases A and B having same pressure P and volume V and absolute temperature T are mixed. If the mixer has the volume and temperature as V and T respectively, then the pressure of the mixer is, all of you are very much aware of Dalton's law of partial pressures. When pressures of course are being mixed up there, what is the effective pressure? It remains the same. Whatever is the pressure earlier we are having, same pressure that is going to be left over there. So what will be the value right now? It will now be P itself. That is actually the concept you people have to take up. So P earlier value is now going to be the present value of P is going to be P1 plus P2. That is the concept you have to take. So what will be the effective value please? This is P and that is P. So total value will now be 2P. Just change that option please. That answer is supposed to be the first one for this one, not the second one. So look at this concept carefully. This is based on Dalton's law of partial pressures. Look at these concepts carefully. These are the problems taken up from expansions of solids, liquids and even gases. But in fact a very important topic of heat is ahead of us, that is thermodynamics and transmission of heat as such. These two concepts over the next few days we are going to discuss about these two chapters thoroughly. Right? Let us check the concepts of heat thoroughly and see that you get one or two questions whatever they give, you work out them in a perfect manner to get the full marks for that attempt set. Thank you.